So I also put section 6.4 and 6.5 together as well because they are similar shapes, kind of like 6.2 and 6.3 was about parallelograms. 6.4 and 6.5 are about rhombuses, rectangles, and squares. So first piece is just knowing what the definitions are. So a rhombus is a parallelogram with 4 congruent sides. And notice that the heading is a special parallelogram, so all 3 of these will start with it is a parallelogram. A rectangle, which is most familiar probably with you, is that it will be a parallelogram with 4 right angles, and notice that it doesn't have the opposite sides already marked. That's because a parallelogram will have those pieces already concluded. And then last, a square is a parallelogram with 4 congruent sides and 4 right angles. So our first problem is we're just going to look at shapes and see if we know what kind of shape they are. So it's saying decide if it's a rhombus, a rectangle, or a square. So number 1, notice I have 4 right angles and I have opposite sides congruent. So my answer would be rectangle. Number 2, notice I only have 4 congruent sides. You cannot assume that those angles are right angles unless they have marked it. So in this case, number 2 would be a rhombus. Now pause the video and see if you can do 3 and 4. Number 3 has 4 congruent sides marked, so my answer would be a rhombus because no angles were marked as right angles. And then last, number 4 has 4 congruent angles and 4 congruent sides, so that makes it a square. So that was practicing what the shapes were. Now you're going to get into some different types of theorems that tell you specifics about them. So the first one, if a parallelogram is a rhombus, then its diagonals are perpendicular. So notice that if I have a rhombus, then my diagonals will always intersect and form a 90-degree angle. The second one says if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So if I have a rhombus, then my diagonal will split these angles into halves so that I know that these are congruent to each other. So we're going to practice finding some measures of angles in a rhombus. So the first question, it's asking me to find what 1 and 2 is. Well, that last theorem we got done reading says that a diagonal will bisect this angle, so I automatically know that angle 1 will be equal to 35 since this diagonal bisects and that makes these two congruent. Then to find angle 2, what I could do is I could find this missing angle. So this is a triangle, so add up these two angles to equal my third. So notice that I got this 90 because the diagonals will intersect and form a right angle. So if I did 180 minus 35 minus 90, I would get this angle, which is 55 degrees. Remember, your diagonal bisects this angle, so if this is 55 degrees, then this angle will also be 55 degrees. Pause the video and see if you can do number 10. Okay, so on the next example, I have this small angle equal to 12, and then I have to find 2, which is in this corner, and 1, which is in this corner. So the first one off the bat that I know is angle 2 has to be equal to 90 degrees because those diagonals will bisect each other and form a right angle. I shouldn't say bisect, they intersect and form a right angle. So if angle 2 is 90, then I could find this third angle. So if I did 180 minus 12 minus 90, it would give me my third angle, which I have marked as 78. Now, keep in mind that if I have a rhombus, then this line and this line are parallel. Going back to first semester stuff, if I have two parallel lines and I have a transversal, then you might end up getting alternate interior angles, alternate exterior, same side interior. So if this is 78, I would know that angle 1 is also 78 because this angle and this angle are alternate interior angles. So kind of tricky stuff here because it applies quite a bit. It applies what you know about triangles, and then it also applies what you know about angles formed within parallel lines. Okay, so next theorem is where we have theorem 615, which says if a parallelogram is a rectangle, then its diagonals are congruent. So rectangle here, my diagonals will always equal to each other. So next question, find the value of x and the length of each diagonal. Well, if they gave me my diagonals, this theorem says they have to be congruent. So I can just set them equal to each other and then solve. So my first step would be minusing 3x. So I would get 7x minus 4 equaling 24. Add 4 to both sides, so I would get 7x equaling 28. Divide by 7, so my answer would be x equals 4. Now pay attention because it's asking me find the length of each diagonal as well. So you want to plug 4 back in, and then you end up getting 36 for both of those diagonals.